Okay. Yeah, you know what? Let me create a new file called lists.py. So today we are getting into Python data structure. The last time we kind of talked about dealt with files, and we learned how to read files. We learned how to manipulate them. We learned that we can open up files, and they have all those new lines, and then we have those uh, data that is inside the file. Basically, the words that were in the text file that we used, and we kind of learned a little bit about how we can manipulate um those words, and we were able to cover up some examples as well. But that 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 was a way to make sure that we can actually participate and understand data structure, because today we will be kind of going a little bit further from just dealing with uh, individual words, and kind of look at how we can use Python to still manipulate our data when they are in when they are in a collection, right? So we're just shifting gears a little bit to look at data structures, which is basically a way of organizing all the data inside our program, so that if we have some of them that are collections, that collections are sort of like if you have like say a number of people, or a list of people, a list of places you want to go, or uh, anything that is more than one can basically it's basically becomes a list. So if you start having item one, item two, like that, that's a list. um yeah, so the list in Python is basically it was the first built-in data structure for collections in Python, because initially Python developed in a way for us to kind of save our uh, save some values in a Python program, and tell Python, hey, remember this, right? Like, we have actually looked at different, we have done so many things before now, where we pick a word or a group of words, and we just assign it to a variable like this one, and then we just tell Python, hey, this is a word, um it means something to me, I want you to remember it, and then we save it to a variable. But at some point you start having not just one something. Probably if you're dealing with people, for instance, you have a group of people, like you have a group of friends, um that's where a list comes in. So you just don't want to put everybody's name, inside inside the a variable, without actually like telling Python how to structure the data, right? So if you do something like this is the simplest way that you can get started. Um, Python just it just lumps everything together, and it remembers it with the variable that you gave it. So, but in this scenario where you have, for example, a group of friends, that's where we can start looking at lists, and typically it looks something like this, right? So this is a basic list in Python. um, Joseph, Glenn, and Sally, these are names of people. It means something to me, and I want Python to remember it, right? So you will notice that the only difference, the main difference here is, we have a square bracket covering these names, these people, and then we have a comma separating each item inside the square bracket, right? So this is a more structured way of us. Is a more structured way to tell Python, to give Python this information. We're not just giving him um we're not just giving him like just a line of text like we're doing here, right? In this case, we are giving it individual items, but we're just saying, hey, just there's a connection between these individual people. That's why I want you to put them together into a list, but make sure that each each item, it's has its own identity, sort of, so that later we can come back and we can access each individual um, item inside this list. So that's sort of like, oh, someone cannot see my screen. Is that, oh, interesting. I didn't know that you guys were not seeing my screen. Okay. Um, can you see my screen now? Oh, okay. Okay, perfect, perfect. Okay, just rumbling along. So, I guess my point is this is what a list looks like in Python. And this is when we are not trying to use data structures, when we are not trying to structure the data that we're giving to Python. We're telling Python, hey, remember this, right? Just remember it with some word that we use as the variable, and we're just saying, hey, Python, remember this. And Python goes, it saves this word and remembers it with the name line, right? So this is your typical variable in Python. So with list, we just move up a little bit, and we'll add square brackets. So we have kind of been using lists a little bit, in some of our previous classes, but anywhere you see a square bracket, that's actually a list. So lists are just a better way to organize the data. So instead of us just throwing these names into apostrophe and just telling Python, hey, just remember this bunch of characters, we are telling Python, we are giving Python more information about the word and how Python can structure it. We're just telling it like we have a number of names and these are distinct items. So we enclose each one, in an apostrophe, and then we separate them with comma, and we make sure that they are enclosed in the bracket. So now Python knows that each individual item on this list, um, it knows how to just treat them separately. So you can think of different scenarios where you would need to do something like this. I don't know, say you have a list of places you want to go. you have a list of things you want to do, and you are trying to maybe create a to-do list for it, for instance, right? So those are different scenarios where you want to, pass in the information to Python in a more structured way. And lists are very, very, very popular, in that aspect. So there are other ways. There are other ways that we structure data with Python. We have dictionaries as well. Um, we also have tuples. So, but we'll get to those. Like I said, list was originally the first way, the original data structure, the first original data structure in Python that actually came in before the rest, like dictionaries and tuples. So we will look at a few examples and see, all the other things that we can do with lists. There are actually a whole lot of built-in functions that are already created in Python that we can use to deal with lists. But we can see we will we'll get to those, in the bit. So just so you know, we can do things like this. So we can definitely, put the names of our friends together and put them in a list and assign it to a variable like we are doing in line 1. We can also have numbers in a list. So a list does not only contain words. You can even add numbers. Python knows that, hey, this is a list, and as far as you are separating each one of them with a comma, Python knows to deal with them separately, right? You can even have a list inside the list. So you could have a list of numbers, that has another list of numbers inside it. So lists are very, very flexible. At this level, you can do so much more with Python, using Python to manipulate your data to achieve whatever desired goal that you want, right? For instance, now we have a group of friends, Joseph, Glenn, Sally, and we just want to tell them Happy New Year, right? We can say print Happy New Year, Joseph, print Happy New Year, Glenn, print Happy New Year, Sally. And that would work. But because you're now a more experienced engineer, you're now someone who is more experienced in writing Python programs. You will not do it like that. Instead, you put those names in a list, and then just use a loop to go through the list and then tell each person Happy New Year, right? So it becomes more complex from here, because when you're writing an actual programming language, an actual say product, like you are building a website, for instance, you might not actually know the names of people you want to tell Happy New Year in advance. Say you're working in a company, and um you are their, say, back-end engineer, and they want to tell people who visit their websites Happy New Year during the New Year season, right? Yeah, you might have some other logic built into your code that will receive the names of the people who are coming to your site. Like we have dealt with inputs where you can ask a user to type in something, for instance, right? So one way is, you can collect those names from user. Another way is, there might be people who are already registered on your website, and maybe you just need to fetch their names from the database. So you will have some other API logic that collects those data, but ultimately you want to put them in a list and then do something like this to tell each one of them Happy New Year. And then if we actually go ahead and we run this code, Let me open up the terminal. No, not right now. And then I can try to run this code, right? List.py. And then we've been able to achieve our original goal. So these are the kind of things that list can do for us. There are several other things that list can do for us. For instance, we can actually we can kind of assess each person inside the list by doing by just looping through them, like we're doing here. But there is something that Python does that you should know. Whenever you give Python, whether it's a word like we're doing here, whether it's just like some random words that we're doing here, or whether it's a list, Python will index them, right? So Python will number them. This is going to be item 0. Joseph is going to be item 0. Glenn is going to be item 1. Sally is going to be item 2, right? Continue like that until whatever number of things you have in your list, right? So you can actually access each item inside the list using this index, right? Instead of going for the actual item, you can say friends at index 0. That will give you Joseph. Friends at index 1. That will give you Glenn. Friends at index 2. That will give you Sally. We kind of saw how we could do this indexing in our previous class with strings, right? So, but the difference is that if we are dealing with a string, Python will index each character inside the string, right? So friends at index 0 will be J. Friends at index 1 will be O, right? Just like that. Friends at index 2 will be S, right? Just like that. But in a list, then Python just index each item in the list, right? So unless you start going into the list and then accessing individual strings or individual words or the individual friends or the individual values inside the list, then you can also actually access the individual characters, like the individual letters that make up the words, the person's name. But if you're using a list, chances are, you don't want to do that. Chances are you're just interested in individual items inside the list, like you're more interested in Joseph as a whole, not just individual characters. So for most things you're going to be doing with lists, you're just going to be assessing individual contents inside the list using indices. The index is just going to be starting from 0. So this is going to be your friends at index 0, friends at index 1, like I said. And I'm going to show you an example. Like in this scenario now, we already have some friends, right? We can do something like this. For I in range, length of friends, and then we're going to print I, and then we're going to print friends at I. So just before we do this, right, just so you understand what we're doing here, we can actually do something like say print friends at index 0, right? So if I run this code, we'll get Joseph. Joseph is at index 0. But if we are not looking for a specific item inside the list, we can just print all the friends, right? So if we do this, we get Joseph, Glenn, Sally. So it's only when we start using index, then we can access individual items inside the list, right? So at index 1, we will have Glenn, right? At index 2, we will have Sally, right? So this is important because being able to access items inside the list is actually very popular in web programming, because most of the things we do on a website to make it work is actually making some API calls. API calls is just something that sends a request message to some other computer somewhere else that maybe belongs to your company where you're hosting your site and you have your database. And then that request will return a list. Most of the time, it returns a list. Sometimes it could be formatted in JSON. Sometimes it could be formatted in different ways, depending on the programming language you're using. And then you now need to be able to, for instance, display the name of the person who just logged in. You have to access the list and be able to locate where the name is, be able to locate the person's first name, the person's last name, and then you'll be able to write your code to be able to display them properly on the screen, right? So that's why it's kind of really important to pay attention to this indexing, because that's a difference that can actually make you a good web uh, developer, if you happen to work on projects like that, right? So we can access we have seen that we can access the items inside the list by using those indexes. So the next thing we want to do is to do the more complex thing, like here in this line 12, right? Right now, we're just trying to say for I in range is a built-in function, is a built-in function that just helps us to, take, if you give it a range, if you give it a number, it will take it from 0 to that number. So if you say range 10, range 10 means 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It stops at 9, I think. I don't think it normally includes the actual number. I'm not quite sure, but we are basically getting the range, which means range. We are also giving, using another built-in function called length, which is another built-in function in Python that we can use to find the length of whatever you give it, it will give you the length, right? So as if you give it friends, it will give you the length, and the length is just going to be the number of items inside the list, right? If you give it just a string like this, then the length is going to be the number of characters in the string. But if it's a list, remember, once it's a list, Python begins to treat them as individual items. So if Python is counting this, it becomes 1, 2, 3, and not counting the individual characters, right? So when we are saying length of friends on line 11, we're just trying to get how many items that are here. So this function will get the number of items inside of friends, and then it basically becomes 3, right? Like this. So we're basically saying range 3, and range 3 will give you 0, 1, 2, 3, right? So that's kind of how it works. And then we are now going to loop through individual. We're just going to use that range to loop through friends, and then we'll be able to print each one of them, right? So if we run this code right now, we'll probably get something like this. Oh, someone is trying to come in. Sorry, guys, please. As always, please, somebody should help me keep an eye in the people who are trying to come into the meeting so that you can always let them in, please. Sometimes people just stay in the lobby forever. So we are just trying to do something more complicated here. You should definitely try this out on your own and try to understand it, because at this point you can start seeing that if we use all these built-in functions and more to achieve a whole lot of things, and trying out these things will actually help you become a better programmer, learn to do more complex things by writing fewer lines and just being able to manipulate data, right, in such manner. So we have been able to itemize all the contents of the friends, and then we've even numbered them. And this numbering is just coming from here. So is this I that we are using, because we are using a loop. So I is just going to be the index for each one of these people. All right. So moving on, I think we have covered the basics, of loops, of lists in general. There are definitely so much more we can do. Like we can look inside the things that are inside of our list and access them, and then use them to do so many other things. Just remember that the index starts at 0 and not 1. So the first item in your list is always going to be item 0, not item 1. That's sort of like the word thing in Python. There are other built-in functions that you can use. Like there are so many other built-in functions that you can use in Python. I will show you some of them. Let me see if we can put this here. Let's forget about these guys. So this is an example that helps us to explore a few other built-in functions that are related to lists. You don't need to memorize any of these guys. Like I always say, this example just lets you know that they exist, and that when you start working with lists, you don't have to build everything from scratch. There are already a lot of built-in functions that does some of the most frequent things that people typically do. So they already created some of these built-in functions that you can just use them without needing to create your own functions, right? So like we have a list of numbers. It has some numbers inside the list, and then we can check the length, right? The length will give us 6, because we have 1, 2, 3, 4, 5, 6 items inside it. And then we can also check the max. Max will tell you what's the highest number in the list. Minimum will tell you what's the lowest number in the list. Sum, you probably guessed it right. Sum will just add all the numbers in the list. Remember, you can have words as well inside your list. So if you have like words inside your list, maybe things like sum might not be able to work. It might throw up an error, because if you're trying to sum up a list, at least make sure that they can actually be added together. You cannot say 1 plus com, right? You cannot add 1 and then add words to it. So if your list have numbers, there you definitely should know these things exist that you can use to manipulate them, so that you don't have to do them by yourself, right? So when you actually run it, you will see the results align with what we have here, right? And then you can even build your own lists, right? Sometimes you just want to, kind of use your hand to create your own list, not just assigning them by putting in some values. Like here is an example of a list, right? We've named this list stuff. And then we can use the built-in function list to create lists actually. So you can do something like this, right? You can also do something like this. This is a list, and this is a list. So just so you know, this when you do this, creates it basically creates this. It basically creates this, right? So, but this looks more professional, so I can just do this. So on line 2, we just created an empty variable called stuff, and we made it a list. And then we now started adding stuff to it. We added book into the list. So we used the built-in function append to add things into a loop, into a list, right? So we also added a number, and then we also added another word. And then we go ahead and we print stuff, and we'll just see that stuff will become a list of all these other things that we added into it, right? So we get our list. So that's one other thing you should know. We can definitely do all those things using lists. It just so that you understand the capabilities of a list. When you start working on a project, you will have very unique needs, and then you will know if a list is suitable for solving your problem. Maybe you have uh, an Excel sheet, that your boss gave you at work, and he said, "Hey, this is a list of our users. We just want to get people who registered recently. We also want to get people who are no longer active. We also want to get maybe people who have already deactivated their account. Different categories of users, and then you might need to just use Python and just turn all those different categories of people into lists, and then be able to access them and be able to present them in a way that um your boss gets all the vital information that they need from that CSV file or Excel document. So that's a typical uh, example that can actually come up in real life. But at that point, you already understood lists, and how to use them. One thing about lists is that they are memory. They are not very memory efficient. So because of that, they are not usually the primary. They are not usually our go-to. We only use them when we need them, because remember, when you put anything in a list, Python is just going to lump all of them together like this, which means all of these are going to be in memory. Assuming we were just creating different variables for each one of these values, and then we just name them separate variable, then Python doesn't need to keep the whole thing in memory. It just needs to bring book whenever you need it. Bring this one whenever you need it, bring this one whenever you need it. But because they are in a list, they are in memory. They are always all in memory. So even if you need only one of these items, like, Python is going to get the whole thing first of all before assessing the single item you need. So because of that, lists are not very memory efficient. When you start writing codes that run into thousands of lines of code, you quickly realize how they can drain the memory in your computer. So that's something to take note of. We use lists, whenever we need to. There is a good example actually that I have that kind of shows you like different ways that you could do the same thing, right? This is a block of code. We just have a variable here, we assign it, we call it total, we assign it 0, and we have another variable acting as a flag. We also assign it 0. And then we're using a while loop to ask a user to put in a number. And then when user puts in number, a user can put in as many numbers as they like, and we'll keep on asking them for number. But once they have put in all the numbers they want, they can now type done. Once they type done, then we'll break the loop, and then we'll now use all the numbers that that user put in, and then we'll calculate the average and print it out to the console. So that's basically what this block of code is doing. But you will notice that we are not using lists. I'm going to show you another way to do this using lists, and then you will kind of understand the memory efficiency that I was trying to explain, right? If I run this code right now, I can give the number to, give another number to, give another number to, and then I can type done. It gives me the average. Of course, the average is 2, right? So this is just a simple program, but there is another way we can write it using lists. We can do this, right? Numbers, we just create a list, all right? And then we do our while loop. We ask the same thing. We ask for the user to just put in numbers, and then when the user put in all the numbers they want, they can type done, and then it will break the loop and continue to the next one, right? So the whole idea is to still get the average, right? But in this case, we are using a loop. But what happens is that each time we are running this while loop, Python is getting the numbers and putting them into a list, but it has to keep all that in memory. So when we actually use this code instead of the previous code that we used, we can achieve the same results, and then done. We achieve the same result, right? But the only difference is that the previous code, this one, is more efficient, is more memory efficient compared to this one. So if we were doing a very simple calculation, and we don't need to use lists, there is no need to use lists. We can always do our thing just using ordinary variables to save the value, and that would make sure that the memory, the software that you're building, it's not consuming too much memory than it's supposed to consume when it runs on the computer, right? Yeah. But when we start doing more complex stuff, you definitely need to organize your work better. So you can use lists, just so it's just a tool that is there, that you can use when you need it. So I guess that's enough about lists. There are definitely a lot more things that we can do with lists, but I'm going to leave it at there because we also need to look at dictionaries and tuples, which are the two other kind of data structures, that kind of works a little bit different from loops, but from lists, but we'll see how they work. We'll see how they differ from each other, and we'll see like the use cases for each one. So let's look at dictionaries as well. In a big picture, kind of looking at it on that level, they are all collections. List is a collection. As long as you start having more than one item, that's a collection. So that's where data structures come into place, because you want to be able to structure the data in a way that it makes it easier to manage in your code, right? So a dictionary is a collection, a list is a collection, right? A dictionary is just a different kind of collection, right? So it can also hold like multiple values at once, uh, just like lists, but um, there is a main difference between list and a dictionary. And the main difference is that in a list, we just put all the items, and then like we did um, in the previous list that we work with, and then you can access them using the position or the index, right? You can access a friend at index 0 and you get the friend there, right? But in dictionaries, it works a little bit differently, right? Instead of assessing things by position, like in a list, we assess them using keys. So a dictionary in Python is basically a list of a list that has key value pairs inside it. And it comes in handy in certain scenarios, especially where you want to make sure that, okay, each item inside your list um, has a name tag, basically, right? So you want to kind of, add a tag to each item in your list. So the key is the tag, and then each key has a value. So it becomes a key value pair. And then we can actually start looking into some examples so that, it makes more sense, right? So, but just know that a dictionary is basically a collection too. It's just a different kind of collection that we could use in in some more specific scenarios that require even more structure, right? Yeah. So let's say we are reading through a bunch of names, right? For instance, we had friends previously, but let's just say we have a list of names um, from a file, and then we want to count how many times each name appear, right? We just have a list of names. For instance, we have let's say, let's work with an example. So this is a list, right? We have names inside it. These are probably names of, I don't know, different kinds of file format or something like that. But you will notice that this one appeared twice, right? And then this one appeared twice, and this one appeared once. And then this because the human brain, that's how, like, we are kind of, it's easy for our brain to just check the number of the each how many times each name appeared in this list. But how would Python handle it? How would Python know how many times each word appeared in this list? So it's actually a very common use case, and this is what the code would look like. First of all, we need to create a dictionary. And the difference between a list and a dictionary is that a dictionary uses curly braces. I think that's what they call this guy. So a dictionary uses curly braces. Anywhere you see curly braces, this one is not just an ordinary list. It's a special kind of list. It's a dictionary, right? So we have our regular list, and then we use a for loop to iterate over each item in the list, right? And then on line 4, we just check if the item is not already in our dictionary, which from the beginning, none of this item is in the dictionary, right? So we check, and once it's confirmed that the item is not already in the dictionary, then we put the item inside the dictionary. That's what we're doing on line 5. And then we give that particular name item that we are putting into the dictionary, we give it a number, 1. We number it 1. So 1 becomes the key. Then the particular name becomes the value, right? So at the end of the day, we'll get 1 CSV, 2 C1, 3 this guy, like that, like that. So they are now more organized. And then we are now checking, once we have already added an item in the dictionary, then that item we no longer need to add it again. So if it's already in the dictionary, then this line will not run. Then Python will just go to the next one, which is the else. So in that scenario, Python knows, hey, I have seen this name before, so I'm not going to add it. So he just goes to the next line, and then he checks that name, that item, and then he just increments the value assigned to it before by 1. So it's just a way for Python to realize that, oh, okay, I've seen this name before, and then I gave it key of 1. Now I'm seeing it again. I need to go back and give it a key of whatever was there plus 1, so that each time Python sees each word here, it just increments the key for that particular value. And that's how at the end of the day we'll get to know how many times that particular value occurred in the list, right? So this is a little more, I guess, a little escalation, because now we are trying to use a list that we just learned, and we're using a dictionary, and we're using them together to solve a problem, right? Yeah. So as soon as we get that stuff, we can, as soon as we have, all this, we can actually go ahead and run this code. Yeah, but nothing happens just yet. But if we now print our dictionary, count, then we'll get that, we'll now see that our dictionary now have some items inside it, and it's exactly restructured our original list in a way that it makes more sense, right? Because now we know, instead of having csv twice in the list, it just tells you that csv is twice. So key value pair, like so. There are so many use cases for dictionaries. That example I gave before, where you are building a website and somehow you need to get data from your okay. So okay, I was just checking the chart. So that example that was given, where you're just building a website, and I was telling you how lists could actually be very helpful, for you to get those names of people and use it to display something on the screen. If you're using a dictionary, it means you can even do something like name this guy, name this other guy, name this other guy, and maybe the user does not just have a name. Maybe he has a name, something, and then he also has maybe location. You could put the value of the location, and maybe he also has the user also have maybe email address. So now you can put all that user information, all the information for that user, and organize it in still organized in a way that it makes sense, and then just assign them all to one variable. So that's the power of a dictionary. It makes sense to kind of experiment with it a little bit. So I will definitely, and encourage you guys to, explore some other examples in your own. Just think about some other scenarios that you could use a list, and try to modify the code to achieve a different goal, I guess, because practice makes perfect. Yeah. So, but on a very basic level, at least now you have some understanding of uh, a different kind of data structure that we can also use, apart from lists, that has more features, that even takes it things a little bit further, right? So there are definitely kinds of um, several kinds of built-in functions as well that works on lists, that you can definitely use to manipulate lists. But you don't have to memorize any of it. Just know that there are always built-in functions. Some of them we can actually try out right now, I think. But being mindful of the time so that this meeting is not just longer than it should be. Yeah, but I could probably just do a few example. So let's say we do something like this. We can do for name in each one of these guys, and then we just want to get the name. Okay. Oh, okay. So this is one of the built-in functions. This is one of the built-in functions. So we can use a dot get on a dictionary to access each individual in the dictionary, and then you just need to maybe just need to pass the dictionary, that's the name of the dictionary, and then pass key the key value that you are trying to access. In our case, we already have these key value pairs. One is 2, one is uh 1, the other one is, so we can actually use a dot get to access each one of them. We probably wanna do something with them. We can probably print them to the console, but most of the time, list dictionaries, they're really more relevant in very complex scenarios. So most times you don't need to use dictionaries. You basically need them when a list will not submit. So if I start to get into those kind of examples that will actually require you to do dictionaries, this might get a little bit complicated. But just at this level, I guess what you need to know is that with lists, you can access individual items. You can use the index of each one to access it, right? It starts from 0. But with dictionaries, we have a built-in function for it, right? So we use whatever the dictionary is .get to access each one. Yeah. And then we have a different kind of list. That's the third kind of data structure. They are called tuples. They are sort of like a list, but I've been trying to understand exactly why they needed another kind of list in Python, to come up with tuples. But the only thing that I could come up with is, basically the lists, the normal lists that we have in Python. This is a list. This is a list in Python, right? And then this is a tuple. The basic difference between a list and a tuple is that a tuple uses your regular braces, your regular brackets, right? That's the difference between a list and a tuple. But a tuple is basically a kind of a list. It just there are some inherent problems that came with lists that they were trying to solve, and that's why they created tuples. So the first one is that lists are mutable. Being mutable in programming terms means that you can change the values in a list, and that's convenient, normally. But there are actually a lot of scenarios in programming where you want to make sure that you want to ensure that that does not happen. You want to make sure that the content of your list does not change, so that you don't run into unforeseen errors in your code, right? But these are usually like extreme cases, specific cases where you want to make sure that, hey, I need a list, but I want a kind of a list that will not change, that the values inside the list cannot be changed. We're not going to somehow accidentally change one of the values in the list and then start getting a different result or running into issues down the line. So that's probably where you want to use uh, a normal braces instead of the square ones. So when you use this type of list, it's called a tuple, and you cannot change the contents of a tuple. So they are called immutable. You cannot change what is inside it. Yeah, that's basically the difference. There are so many built-in functions that are also available for lists, and most of them are available for tuples as well. But there are probably a few difference. Um, there are some of the built-in functions that works for lists that will not work for tuples. The first one is sorting. If I remember correctly, you can sort the items in a list. And basically, if you sort the items in a list, sorting might mean maybe we have three here. And then when you say sort this, Python will basically sort it in ascending order so that one comes first, which automatically means that this list have changed because the position of the individual items in the list have changed. So we cannot use sort on tuples for obvious reasons, because like we say, tuples are immutable. So you can't change what is inside it, whether it's just the order that they appeared in the list. It's not allowed. So if you use a sorting built-in function on a tuple, you will likely run into some errors. There are other built-in functions that makes modification to the original list. So I guess same goes for each one of them. We have built-in functions like append. You cannot append something into a tuple, right? So just your normal regular list, but they just have a lot of restrictions. So they decided to call it something different. They call it tuple. So a tuple is basically, a specialized kind of list. So every other thing you already know about list applies to tuple, except all the things that intends to change the values inside the list. So those scenarios will not work for tuples. And those are actually the three main the kind of data structures that we use in Python, and so many softwares or applications that you'll build in the future or you're going to come across. They're going to be using different varieties of each one of these data structures. So it just makes sense for you to kind of understand how they work. Now that you do, we can get into the next thing, but that probably should be next classes. Some of the next classes we'll have, we'll kind of step up a little bit and deal with another advanced concepts in Python. But in the meantime, if you have any questions on data structures, on lists, dictionaries, and tuples, yeah, now is the time. Any questions? Okay, I don't see any hands, so sounds like a successful class, and everyone, there was no confusion whatsoever. Thank you guys for showing up today once again, and enjoy the rest of your day. Bye.